All right, we're on page 2 of lesson 5. We were still talking about min and maximum examples. Number 4, the patient has an illness that typically lasts 24 hours. The temperature T in degrees Fahrenheit of patient T hours after illness begins is given by the following. So, just to be clear, sometimes I like to go off to the side. Excuse me. There's a lot of letters flowing around here. So, just to be clear, the small t is kind of the x, and the large T is the y, okay? And they're talking about the small t being the hours after the illness begins. Okay, so this is in hours. And the T is in degrees Fahrenheit. Okay, just to be clear about what they stand for. When does the patient's temperature reach its maximum value? So just to be clear, that A right there, this is in the proper order, so it's less than 0. Therefore, the parabola, hang on, just to get all my papers, I should be looking at the key while I'm doing this to make sure. When the A is less than 0, the parabola opens down. You can remember that, or it asks what the maximum value is, so it's telling you it opens down, because there's only one way that works, is that is a max, right? And then it goes infinitely down, so it has a max Y value, okay? So I need the Vertex formula. You can write it here, you can write a X or whatever you want to do, but either way it's negative B, so the B is a positive 0.572 in this case, over 2 times A, which is a negative 0.026. Make sure you're multiplying first, the bottom, and then that top number divided by a negative is going to come out to 11 hours after illness begins. All right. Sorry. Just looking at 10 different things at one time. 11 hours after illness. So the minute people get sick, the clock starts. They get sick with this particular illness, and apparently 11 hours after the illness begins, their temperature is going to max out at, haven't calculated that part yet, but apparently it's going to happen in 11 hours. So what do? We want to know the temperature in 11 hours. So we're going to substitute 11 in for everywhere there is an X, not an X, it's going to be a little T in this case, 2, 6, if I can ever get there. Put 11 here, plus 0.572, and 11 here, 9.7.5. Okay, so mathematically, orders of operations, negative 0.026 times 121, plus whatever this is multiplied together. All right, so this is going to be T11. This is going to be this number times this number, plus this plus that is 100. That makes sense. You can have a temperature of 100, right? And a little more than 100.5. And that is your maximum temperature you get 11 hours after the illness begins. And then hopefully your temperature starts going down after that, right? According to the math. All right. An architecture is designing an office building. The building is to be a rectangle in shape with a perimeter of 360 feet with a width of W. We don't know how wide it's going to be. All the way around, perimeter all the way around is 360. So how do we make a kind of a rectangle out of that? or a square. Squares are rectangles. So the following represents the area of the building in terms of width. Find the maximum possible area. So think of the variables here. This is the width is kind of acting like the x, right? X squared, w squared. And the area is acting like the y. And this is, but they're both in feet, okay? Think how they got this problem. If the whole perimeter all the way around, if the perimeter all the way around is 360, then half of it, L plus W, just one of them, this plus this, is going to be half of that. 360 divided by 2, that gives you your 180. And the area, remember the formula for an area is length times width. So the area is going to be the width or times the length. And the length is going to be, you can represent it as 180 minus W, right? What's left is the length. So you put that together and you're going to get 180W minus W squared. Okay, we don't make you come up with the equation, but I want to explain where that's coming from, okay? Basically, you need to do the maximum area possible, which means this is going to be a max, which means this is going to be a parabola that opens down, which makes sense because A is a -1 in this case, right? And B is 180. So what is the maximum? We need to get there. So let's follow the vertex formula is the only thing we can do first when trying to find a maximum. We must do the vertex formula, which says opposite B over 2 times A. So -180 over -2 equals 90 feet. So that means, oh, don't put a T. That's a little confusing. That was from the last problem. What do I want to put here? This is the X or the W, okay? So the width is apparently 90 feet. So what is the maximum area? So remember, width is 90 feet. This is the space inside is the area, right? So the area, with the width being 90 feet, means substituting in the 90. So -90 squared plus 180 times 90. Put that all in your calculator. Don't forget that is -1 times 90 times 90, right? That should come out to 8,100 feet square as the max area possible. Okay, so on the next page, page 3, the next skill says follow the steps below to find the vertex, which we already figured out how to do, but now it wants to talk a little more about the Y-intercept, the X-intercept, and the domain and range. All right, so these are not word problems. These are abstract problems with just equations to find this information that we want to be able to sketch a graph. Okay, so we're not just putting things upside down or right side up. We want to know where on the coordinate rectangular plane, the graph this goes. Does it go like this? Does it go like that? Does it go here? Where does it go? Okay, so we want to start with problems that are abstract. All right, so how do we do all of that? We know how to find the vertex, right? Step 1, write the quadratic in the standard or general form. Identify what ABC is, all right? If A is greater than 0, then the parabola opens upward and it has a minimum value. If A is less than, if it's negative, it opens downward with a maximum value. That's a fact, okay? So it helps when you start to graph to find the vertex first, okay? So once it's in order and you understand the general appearance of this, up or down opening, You need to find the vertex to find that one point to put on the graph as the starting place. Where is it going to go up or down from? Find the vertex using the vertex formula. Start with the formula to find the x-coordinate, right? This is the x-coordinate of the vertex. Once you find the x-coordinate, you use it to find the y-coordinate of the vertex. Okay, these are the steps. We've been doing that part. Then it wants you to find the y-intercept. Think about it. The y-intercept, this is the y-axis, this is the x-axis. The y-intercepts are along here somewhere, is one y-intercept. So that means, let's say you have a parabola that kind of goes like that. It's going to go through in one place. Let's say you have one that kind of looks like that. It's going to go through your y-axis in one place. Its ordered pair is going to be 0y. Okay? To find that, we're going to, because this is 0, we're going to substitute 0 back into the quadratic equation and find out when x is 0, what is y. And that will tell us our y-intercept. Okay? The x-intercepts are what you get when you solve the quadratic formula. Right? The discriminant can tell you how many answers you have. If the discriminant is positive, there are going to be two real solutions, and you should be able to graph them. So when you get, when we were factoring or solving for x and we got a 2 and a -1, this would be the x part of the ordered pairs for the dots on the line, okay? So think about it. If it has two x-intercepts, that means it's going to go through the x-axis twice. So it could be upside down, it could be here, right? It's going to have two. The 0 discriminant tells us there's one real solution, and the graph is going to bounce off the x-intercept. So if there's one solution, it's going to come down and kind of hit like one spot. It could go like this and actually hit it 0, 0 or something. But it has to only touch or intercept the x-axis once if the discriminant is 0. Okay? What happens with the 2 complex when you have an I? When you have an I, mathematically there will be no x-intercepts, because what's going to happen visually is this parabola is going to kind of hang up here or down here. It's not going to touch the x-axis, so there will be no x-intercepts. Okay, that's how it's going to come out mathematically when you have a negative discriminant. So let's look at these examples here. Then you're going to state the domain and range, which we know how to find. So here's 2 examples. This one here and this one here. And yes, all of this is how to answer this information. So let's look at this example A first. It's in the proper order, so therefore the A is 2, the B is -1, and so is C. All right? So if the A is greater than 0, that means A is a positive number. In this case, it's a positive 2. Therefore, it has a minimum value. So if it has a minimum value, it's going to open up somewhere. Okay? Then you're going to find the vertex because you want to start graphing it. So the vertex, follow the vertex formula. Negative opposite B is a -1, which is a +1, and 2 times A is 2, which is 4. So that means the vertex has an x value of 1/4. So that's kind of hard to graph, but that's what it is. Then you use that minimum, the x value to put in and find your minimum value for the x and the y here. This is 1/4. And then if we put this in here, crunch it carefully, this is 2 times what? This squared is 1/16, 2/16, 1/8, so forth, minus 1/4, minus 1. So this would be, how do I make this over 1/4? This is going to be 2/4. 1/8 is 2/4 minus 1/4 minus 4/4. Does that come out to 9? Should come out to 9. 2, 4, 5, 6, 7. All right, let's try that a little slower. I was relying on my calculator when I did that. Oh, I didn't multiply it by 2. That was the problem. Okay, so this all comes out to negative 9 over 8. In this case, you could turn it into a decimal. It's going to be repeating, though. So it's just an estimate when you try to graph something like that. Usually the ones that you have to literally put on the graph on the homework will have whole numbers. Or at least half numbers, so you can be exact with your answer when you put them on there. But theoretically, this is the vertex, with the minimum being negative 9 over 8. And I could try to make a little graph right here. Let's see, 1/4 positive makes it on this side of the line and down because it's a negative. So let's say that's 1/4 negative 9/8. Okay. Now find the y-intercept. Y-intercept means the x is 0. If it's going to intercept the y-axis somewhere, the x has to be 0. So I'm putting the 0 in everywhere there is an x. And that comes out to a negative 1. So 0, negative 1, let's go with about there. Okay, there's my y-intercept of this quadratic equation. I'm going to calculate my discriminant. My b squared is negative 1 squared. And then it's a negative, remember the formula, b squared minus 4 times a times c comes out to a positive 9, which means it's going to be 2 real solutions. So we need to figure out what they are, and it turns out this quadratic actually factors. All right, so use the factoring method to solve for x, which involves factoring them out with a guess and check, and then or trial and error, or whatever you want to call it, then setting each factor to equal 0 and solving, so I get a negative half and a 1. Therefore, my 2 intercepts to graph them are negative half 0, and 1, 0. So that's the best guess without graph paper, right? So this is just a sketch of what this would look like with the key points written down. Okay? So look at this one over here. This one has a negative 1. It's in the proper order. Negative 1 is A. B is a negative 3. C is a negative 4. Since A is negative, the parabola opens down, having a maximum value. Opens down, having a maximum value. Okay? Step 1, find the vertex. Step 1 of the vertex, use the vertex formula. X equals negative b over 2a. Plug those numbers in. Don't forget the double negative makes a positive, but the negative on the bottom makes the whole thing negative. If you're trying to graph these, you can find the decimal of these, right, just to get an idea of where it goes on the graph. But like I said, if you have to graph them, you will end up probably getting something with whole numbers. But this is just showing the methods, because a lot of these you just have to crunch out and tell them what they are. So I replace this everywhere there is an X and do the math for that. So be careful with these. This is 9. Let's see, that's going to be a positive. Well, no, it's going to be negative. Yeah. Negative. So this is a 9 over a 4 negative. And this is going to be a negative 3 times a negative 3 is a positive 9 over 2 minus 4. Eek. Okay, so 9 over 4 plus, what is this as a 4? Times 2 is 18. Minus, what is 4 over 1? 4 is 16. Gracious. So negative 16, negative 18 is a positive 2, negative 9. That makes the negative 7 over 4. Yep. Okay. And then 4 into that is kind of a negative 1 3/4. That's kind of hard to graph, but if I needed to, that's what I would do. All right. Remember, we're just following all the rules we did on the first page for the vertex. And then to find the one Y-intercept, there will be one Y-intercept. Sometimes it's off the page. Sometimes you'll be able to see where it is, okay? Sometimes you'll be way over here somewhere and you won't, and the Y-intercept will be off the page because it's way up here, okay? But there should be one. There is one X-intercept or Y-intercept somewhere because these parabolas expand as they get larger, right? So to find it, any Y-intercept is a 0y. So it'll have a 0 in the X. You put the 0 in for the X, solve, you're going to get a -4. Okay, I'll graph this one in just a second. A little sketch. All right, the discriminant, b squared minus 4 times a times c, is going to yield a negative, which means there are no X-intercepts. And that means it's not going to touch the x-axis, and there will be i's in my answer, in my solution. So sure enough, when I crunch out, I have a discriminant of -7. I got to take that I out, and these are my two complex solutions, so therefore there are no intercepts. And, I forgot to talk about the range on the last one. Domain's always that. But think about this. What is this going to look like? Let me try. So this is here. And the only solid number I have is the Y-intercept was 0, -4. Let me put that in. 0, -4. And the other ones were decimally, so... But they were definitely in the negative category. So they're like over here somewhere. 1.5, and then down a couple. Let's just really guesstimate this. It's a sketch, okay? So the vertex is there, and it opens downward. So this is going to come around and apparently go somewhat like that. Those are the only points I can really put on there. So think about your range. It's going to go down and out. As it goes out and down, it's going to have a range of a -infinity, but its max is this vertex right here, which was what? It was -3/2 and a -7/4. Okay, so the 7/4 is the highest it will go, the max y. Okay. Over here, the range goes down. It has a limit on where it goes. Right here, that's the y. How far down it goes. What was the x? The x is 1/4. Okay. So on the next page, there's a bunch of blank space for you to do this all for these problems here. Okay. So I need to do another video for that. Okay.